You can do that on the graph, right?
We're going to graph them, but not today. So today I'm just going to teach you about what a logarithm is and how to rearrange it. So logs are just other ways to write exponents. In fact, if you think logs are, I don't know why that looks like that, exponents, okay?
E-X-P-O-N. What? You put in two P's.
Oh my gosh, I told y'all it didn't feel good.
See, that's what I'm saying. You don't need to.
Exponent.
It's going crazy, bro, on DD.
So that's what log means in the calculator?
Yes, but your calculator, stop. Your calculator only does certain bases, and I'm going to talk to you about that in just a second. Let's say I have, and this is red. Okay, I'm sorry. I'm going fast today. I feel like I'm going like turtle slow.
Okay, I don't know.
It's true. You read this as log base B of A. Bless you. This is what we call logarithmic form. Logarithmic form. Now, I can change, because logs are exponents, I can change from logarithmic form to exponential form. And to do that, I take the base. What's the base? B. Remember base B? So B, I need the exponent now. X, because the logs always equal the exponents. So B to the X, what do you think it equals? There's only one other variable left in that equation, A. Okay, so we can change forms back and forth, and I always tell students, as long as you have the equals on the right side, you can say B to the X equals A, and it looks like an E for exponential form. That's one of my little quirky tricks. B to the X equals A, and it looks like an E for exponential form. All right, so we're going to practice. That's one of my little stupid tricks. It doesn't work, though, if you write X equals log base B of A, and everybody's going, what? I don't understand, because it's, just make sure it goes, yeah. All right, so let's practice with a couple and see if you can change the form. Let's do logarithmic form here, exponential form here. I like logs a lot. Why?
I like ants on a log. I haven't had one forever though.
Okay. Look at the first one. If you change the form to exponential, what does it look like? What's the base? 2. What's the exponent?
3.
What's it equal? 2 to the third equals 8. 2 to the third equals 8. Does that make sense? Y'all still copying the problem, or am I going too fast? Yes, Miss McGee. No, ma'am, we're good. Okay,
Should
class.
you reply yes to that?
All right, look at the next one. This time I'm going to take it from exponential form to logarithmic form. So log, what's my base?
5.
5. What's the a there? Log base 5 of 25 because it has to equal the exponents because logs equal exponents. Does that make sense? Is anyone confused on the third one?
And then you would know that 2 times 2 times 2 equals
Correct. It's another way,
5
right.
25. What?
That's correct. It's another way to write exponents. That's right.
You know it's right.
Yes. How about the next one? What's the base?
Base is 1/3.
What's the exponent?
-3.
What's it equal?
27.
Does that make sense?
No.
What do negative exponents do?
Hey guys.
Negative exponents make it reverse or flip. So
Yeah.
if you flip that over and make it positive, what's 3 to the third power? 27.
That is 27.
That is 27.
So that does make sense.
It does make sense. How about here? What's the base?
A half. No, sorry, 81.
81 of,
Of 9 equals a half.
does that make sense?
That?
A 1/2 exponent is the same thing as what?
25.
Square root. What's the square root of 81?
9.
Does it make sense now? Okay. So we might can rewrite them. Let's see if you can evaluate them.
Okay.
I'm glad you got the charcoal because I'm
Hold up, can you go back?
Oh my gosh, that was so not even funny. All right. Oh, I meant to put evaluate. Which means, tell me what it equals.
Do 25 can be square rooted.
Do what?
125 can be, 125 can be square rooted.
But what process, think about what you're asking yourself as you find what this equals. Logs equal exponents, so I'm wanting to know if this is my base, what do I have to put as the exponent to get it to equal 125?
5 1/2. No, sorry.
3.
Oh, because 5 3 times.
Because 5 times 5 times 5 is 125. Yes? Brianne, that's not your seat. This one's harder.
That's 3.
It's the same problem.
Nope. Don't blurt it out if you get it. Try,
Oh, that one.
see
Oh,
what.
which one? Oh, you talking about
The green one, yeah.
Oh, I thought you were talking about.
Log base 5 of 0.2. You know what it is?
Wow, I ain't know. I ain't know it.
Grant knows. Does anybody else know?
Oh, equal 0.2?
0.2.
You're going to be square rooted.
Don't know. Wait.
Let me give you a hint. Write the decimal as a fraction.
See, if it was a decimal, then I would have got it. But
It is a decimal.
it's 210. I mean, like.
It's 0.2.
Yeah, which is what?
Is it up 0.2 or is it down 0.2? Is it like squared?
So it's -1?
It's not negative. Is it point?
Yes, Landon. Yes, Landon. Yes, Landon. Yes, Landon. Shh.
Oh, I thought you were talking about the 0.2.
Is it -1,
Is
Landon?
it negative? No.
Shamik. Psst, psst. Yes, Logan's got it. Some of you look confused, others of you are like, oh, a light bulb just went off.
Times? Is that times 2 or point?
No, that's log base 5 of 0.2. So what exponent do I need to raise 5 to make it 0.2? And my hint was to make this a fraction.
I made it 1/5.
That made it 1/5. So what exponent do you have to raise 5 to
1.
make it 1/5? Close. Negative 1. Because what does a negative exponent do?
What?
Flip. That was a good one. Sure it was. That was fun. It's okay. Base is 36 this time. It's got to equal 6. What exponent do you need? 36 to the what power gives you 6? Yes. Why, Kim? Square root it. 1/2 exponent square roots it. Does that make sense to you all? Okay. Do we need to do a couple more? Y'all got that? What if I asked you, what is it? -2.
What?
What do I have to raise 1/5 to make it equal 25? See how I'm having to really depend on going from my logarithmic form to my exponential form? You really have to know how to do that.
A -5.
2. Because to flip it would be the negative. The negative would make it flip. And then what power do you need to raise 5 to get 25? 2. All right, so we have 2 types of logs. You know, in math, there's always those implied numbers that are there. If there's a square root without a number, it's an implied what outside the radical? 2. If there's a number without an exponent, it's an implied 1. If there's a log without a base,
0.
it's a 10.
Why?
Because our number system is a base of 10. We go from 1 to 10, and then we start over 11, 12, 13, adding the numbers. It's a base 10 number system. So logs, if there's no base indicated, then it's 10. And this is what we call a common log. So if you just hit the log button on your calculator, it's going to just do a base 10. We also, which is even more common than the common log, ironically enough, this is an L, not a 1, have what we call a natural log.
So ln.
So the natural log of x is the same. Guess what the base is going to be on this?
L is
Can
the
you
natural
guess?
log.
ln. It's natural log. Natural log is simply a log that has a base of e. That e we talked about, it's got a base of e.
I don't understand natural log.
It's just log base e. That's all it is. Log base e. And there's a button on your calculator for that. Tell me this. If you were asked just to simplify this, think about this for a minute. If I had x to the third equals, actually no, let me do 3 to the x equals 3 to the 12th, what would you tell me x equaled?
12.
12, right? There's nothing else it could be. It's got to be 12. Use that a little bit if I'm trying to find what this simplifies to. 5 to the what power gives you 25 to the x. Close. I need to somehow find a way to force the bases to be the same. How could I do that? How can you write these two numbers with the same base? One's already 5. How can you write 25
Oh, 5.
to the... Do you agree with that statement? Is 25 the same thing as 5 squared?
Mm-hmm.
Yes or no? Oh my goodness, y'all. So really, I could change this to log base 5 of 5 to the 2x. Do you agree with that?
Yes.
Yes. And it would have to equal what? 5 to the what power gives you 5 to the 2x? 2x. That is a property of logarithms that tells you if the bases are the same here and this has some exponent hooked to it, all of this just cancels and leaves you with that x there.
All of it?
Mm-hmm.
Like, which part?
So here, because this was log base 5 of 25 to the x, okay? I rewrote it as log base 5 of 5 to the 2x. Now we came over here and derived why it is what it is. But the property tells you anytime that these two numbers are the same, then it equals whatever this exponent is. But I really wanted you to see why. So if I had, y'all got that? Log base 12 of 12 to the 5x. What does that equal? 5x. What if I had log base 13 of 13? What does that equal? 1. Does that make sense? If the little base and the a are the same, then you take the exponent on the a and that's what it equals. The reverse of that property is if I start out with a certain base, like let's say I had 5, and the exponent here had a base that was the same as this, what do you think it equals? What?
Log base of 5 2x. Log 2x.
It just leaves the 2x. If this base and this base are the same, these cancel and just leave this. And those are properties that you could easily derive as you start going through working properties of logs. One more thing to show you and I'm done, I promise. The best part. No, I think the evaluating is the best part, but okay. Oh my goodness. Don't be a poo baby. If I have an equation, and this is going to come in real handy when we start graphing tomorrow, as in, how would I find the inverse of an equation? Switch x and y. We learned that way back, right? We switch x and y, we solve for y. So if I do that, right? But my goodness, how do you get an exponent by itself like that? How do you solve that for y? Well, I would have to y-th root it, right? Because whatever this is, that's the root you would have to do to get rid of it. So that's not going to work. The trick here, and I'm asking a question you don't know the answer to quite yet. Logarithms solve exponential equations because logs and exponents are inverses of each other. Okay? So if you isolate the y piece, your new y piece, then you can change the form. How would you change the form on that? Log, what's the base? Of x equals,
Y.
is it solved for y? Yes, y is by itself. These two equations are inverses.
I guess they're basically inside out.
What? Their bases are what?
They're basically inside out.
Oh, yeah. So here, this was a growth, right? So it's probably going to look something like this.
This is going to go down.
Now this is going to be like this, where my asymptote is now flipped. They're inverses of each other. Remember what inverses do? Flip them around. Let's solve another one. Find the inverse. Yeah. Yeah, I'm sorry. First. Now, I said something about isolating the log piece. And in this case, the log piece is isolated because these are all hooked with the log because of the parentheses, okay? Now, we haven't changed form with a natural log quite yet. So what does it look like when you change form with a natural log? What's the base? E.
Because with E it's just exponent.
What's the exponent? X, because logs equal exponents. Y plus 3.
So basically,
Again, it's flipped around, y'all, so it doesn't make the E, but you could write it as log y plus 3 equals x, and you could do it this way. Does that make sense? Is it solved for y yet?
you can move the 3 over.
You need to move the 3 over. So whenever I move the 3 over, I get e to the x minus 3 equals y. Now that's the inverse. Let me show you one more. You have to do a little bit more manipulation too, but that's it. I'll let you do your homework. Oh my gosh, what? Shami. Oh no, we are supposed to graph in this section. We're not going to graph today. Wow, this is a very involved section. It hates you. Maybe we should. Oh no, I've been recording now. Y equals log, let's actually do 1/2 log base 3 of x plus 1 minus 4.
8.
I like this one.
So, and then the E part of the whole thing.
If that's a natural log. If it's a natural log, yes, you would do the e.
So what do we do now?
What do you do? Switch x and y. That's always what we do whenever we're finding an inverse. Now this one's a little bit different because in this case the log piece itself is not isolated. So I want nothing but the log piece. So what can I move away from the log?
4.
The 4 that sits out there, because
That's 4.
all right, so now I've got x plus 4 equals 1/2 log base 3 of x plus 1. Does that confuse anybody? Ah! Now what? Is it isolated? No, almost. What's still hooked to it? The 1/2.
Multiply half.
By 2. Because that's going to get rid of it here, but if I do it here, I must also do it here. Alright, so now I've got 2x plus 4 equals...
2x plus 8. We could do it like that.
You could if you want to, sure. Can you get y by itself now? Yes. How? Because the minus 1 is hooked with the log. What can you do? If you ever get stuck with logs and exponents, try changing the form.
I watched it. Never mind.
What's the base?
3.
3. What's the exponent?
Y.
Sure. Logs always equal exponents.
It's either y or
So what's the exponent?
x.
All of this is the exponent.
Oh, because it equals that.
Logs equal exponents. Always. That's why we got it over there to see what all goes in this exponent. So 2 times x plus 4. And if you expanded that to 2x plus 8, it is okay. What does it equal? Y plus 1. Now can you isolate y? Subtract 1. You are smart. Yes. There is my final inverse.
Why aren't you putting it through? Why aren't you putting it through x?
She doesn't have to.
You could put 2x plus 8. Tell me what you think.
Okay, that's good.
Yay or nay?